Hello students, this is your instructor. So this video was created to kind of help students guide them through week 6 of the semester. So that was March 15th through March 19th. You may be getting this video late, so I do apologize for that. But hopefully this will help you review and to kind of help be on track for the semester. So here are our general deadlines. So Chapter 1, Chapter 2, and Chapter 4, if you wanted to keep pace with the class, they should be completed by now. However, you may have a 0 in the Canvas gradebook, but you can still get full credit since the actual deadline for all homework for the entire semester is June 6th. The next assignments are Math Video Number 1 and Math Video Number 2. Those have set deadlines. And unfortunately, they are in your gradebook and it is not graded, but the deadline has passed. That means the assignment is locked. I am trying to grade them as fast as I possibly can to give you feedback for, the remaining math videos. And of course, we have our discussion post, number 1 through number 5. That's due every week. So part A is due on Friday and part B is due on Sunday. And that is the same for the entire semester. So just know there's always going to be 2 deadlines for the discussion post. Now we're going to go on to the next page where we are going to be going over some key problems from the homework. In particular from the homework, and remember Chapter 4 in Newton, you only have 11 questions in this entire chapter. So it is a pretty dense chapter, but it should be pretty quick, or at least not very long. So from Chapter 4, specifically from Newton, it says find the linear regression line for the following table of values. You would need to use a calculator, spreadsheet, or statistical software. And of course, in this class, what we are using a graphing calculator, okay? So we are going to be using regression, and it tells us that we want to round the values to the nearest hundredth. So that's going to be kind of our first thing, is to make sure that we find a linear regression line. So we can say that's part A, or the first part. And then the second part says find the value of y at x is equal to 8. So this you can say is going to be our part 2 or our part B, okay? And of course, we're still going to be rounding to the nearest hundredth if possible. So using your TI 84 or 83 or your plus or your CE, whatever you have, if you have a graphing calculator, then you should be able to do this problem. So I'm going to go ahead and bring up my calculator here. So now that I have my calculator here, that can kind of help me. So here I have already went ahead and wrote out the calculator steps, right? So the first thing is to make sure that you turn it on. So the on button, if you need to see it, it's right where it's red, so you press on. So now you know that your calculator is on. Now the next thing you want to do is you want to go to Stat. So now you're in Stat. And then you want to go to Edit. So I'm going to go ahead and press Enter. And then from there, I want to make sure that I enter in my X values into L1 and my Y values into L2. So if your calculator, like mine, already has stuff in it, go to the very top where it's actually shaded on the L1, click on Clear, and then go back down. And for L2, same thing, go to the very top, click on Clear, and then go back down. So that clears all of your values in your L1 and L2. So like I said, in the L1, you're going to put all of your X values. And now for your L2, you're going to plug in all of your Y values. So I went ahead and, like I said, I put all of my X values in L1, and now all of my Y values are in L2. So now that I have all of my values from the chart onto my calculator, the next thing I want to do is I want to actually have it compute the regression. So I'm going to go back to Stat, and then you can click the arrow button here so that you're on the calculator button, so calculate. And then you want to scroll down till you get to number 4, which is linear regression, so lin-reg. Click on Enter, and you can either go down or you can click Enter, whichever you prefer. But once you're on calculate, go ahead and click enter, and it'll give you your linear regression. And so remember that you are rounding to the nearest hundredth, okay? So that's the decimal, so you're rounding 2 decimals. So I'm going to go ahead and write that down on my screen. So I went ahead and wrote it down. So from the calculator, right, we just computed it, and if I round it to the nearest hundredth, which is asking me to do, then I get that y is equal to 0.66x plus 3.85. So that you can say is, your part 1, I guess you can say, right, or your part A. Now for my part 2, or if you wanted to call it your part B, that's fine. Remember, I said to specifically find the value of y when x is equal to 8. So what happens when x is equal to 8? So I'm going to go ahead and plug that into my equation. So I have y is equal to 0.66. And now that I see this x here, I'm going to make sure that I plug in this value of 8, since that is what I'm given for x, and plus my 3.85. So once I do that, I'm going to get that y is equal to a 9.13. So that is my answer, rounded to the nearest hundredth. So problem number 2, it says the truck costs $10,000. It depreciates in value $4,000 per year. Write a linear model in the form v of t is equal to mt plus b, where v of t represents the current value of the truck after t years of ownership. So for this problem, what is it really asking me to do? Well, it says to write a linear model where it looks something like this. So you're just like, okay, so a linear model, and that equation or that model looks like v of t is equal to mt plus b. So if you want to think of something that is familiar, you can think of the y slope-intercept form. And we learned that in our last chapter. So remember, we had y is equal to mx plus b, where m was going to equal to your rate, and your b was equal to your y-intercept. Or if it's in a word problem, it would be your initial value. Okay. So what does your rate really tell you? It's telling you how much it is changing. So if I take that into consideration, well, I know here that my b or my y-intercept is my initial value, and so the truck is going to be initially $10,000. So I know that my initial value, my b value, is 10,000. Now, the next thing that I see is going to be my rate, or my slope. It depreciates in value 4,000 per year. So this is the change. And not only is it the change, the fact that it says depreciates, right? That means you are losing money. So that is a negative. So since that is a negative, I can say that my slope is equal to a negative 4,000, because that's how much it's losing money per year. So I know that my m, my rate of change, is a negative 4,000. That means every year the truck loses $4,000. So now, since I want to plug it into the equation, remember, I'm looking for y is equal to mx plus b. Well, then I have my m value. So y is equal to my negative 4,000 x plus my b value. And remember, I said that my b value was 10,000. And now, really, the only difference is they specifically wanted to write your linear model with this notation. So now this says, okay, instead of the y value, I'm going to say v of t because it's a function, and it's equal to my negative 4,000 x plus 10,000. And so that would be my final answer for this problem. For this next problem in Chapter 4, it's a word problem, and it says a farmer notices that there's a linear relationship between the number of beanstalks n she plants and the yield, y. When she plants 4 stalks, each plant yields 120 ounces of beans. When she plants 9 stalks, each plant yields 220 ounces of beans. Which of these equations correctly represents the situation? So in this case, you can use your graphing calculator to kind of help you out. So what's kind of going on is you have to make sure that you understand kind of our vocabulary here. So we want a linear relationship. Hopefully you remember, for our linear equation, we must refer to that as the slope-intercept form, which is the y is equal to mx plus b. And what they have given us some values. We have stalks, and we have how many it yields, right? The number that you start off with and how many it gives you. So you can kind of say that you have X amount of stalks and your Y amount of yields. So you have your X and your Y. So now you have these two different values. So you know that the first number that they give you is 4 stalks. So that's an X value. So here you have a 4. When you plant 4 of those plants, you get 120 ounces of beans. So here, so when we're given that 9, we can say X is equal to 9. And so our Y is equal to 220. So now that I have these 2 points, I'm like, oh, perfect. I can actually go ahead and plug into the calculator and do the linear regression. So if I have that linear regression, I'm going to go to Stat. I'm going to go to Calculate. Oops, no. Stat, Edit. There we go. And look, our X values are already in L1, and my L2 values are in my Y values are in my L2. So now I'm going to go to Stat, Calculate, go down to Linear Regression, click Enter, and you keep going down or keep clicking on Enter, and you get your linear regression, where here your slope is 20 and your y-intercept is 40. So in this scenario, you're going to have y is equal to a 20x plus b. Now the only difference here is going to be the notation. Notice how all of these notations is y of n. Every single option. So you're just like, okay, well if that's the case, I need to change this to y of n is equal to 20n plus b. So I'm changing my slope, or changing my variable x to be n, okay? So in this case, the best scenario is going to be this one. So I would click on this answer for y of n is equal to 20n plus b. In addition, for Chapter 4, we're going to be looking at different graphs, and in particular, this question is asking us which of the plots below show a linear relationship of y and x. Select all the correct answers. So again, if we are looking for that definition of a linear relationship, visually, we want something to be sort of a straight line, and it can have either a positive or a negative slope, and maybe it can follow something closely to that y is equal to mx plus b. So we know that this graph over here looks kind of like a U, almost like a parabola. So this is not linear because it bends, okay? But the other ones that look like a line, I would say would be these two. These are very, very close. So I would say that this one and this one would both have linear relationships. This first one is not selected because they are more scattered plots or points, versus the ones that are highlighted are more condensed, and they do definitely have a type of linear relationship between the y and the x value. Hopefully you guys have started the chapter 7 homework. It's a total of 14 questions. So for this problem, it says find the solution to the system of equations by graphing. So you definitely want to be graphing this equation. So I'm going to graph this equation in different colors to kind of help myself out. So I know that this first equation, I have x plus y is equal to a negative 1. Well, to get the y by itself, I'm going to go ahead and subtract x to both sides. So I can get that y is equal to a negative x minus 1. And you can think of it as a 1 in front of the x. So really you have x plus, you really have y is equal to a negative 1x minus 1 for that first equation, okay? So we can say that my slope is a negative 1 over 1. So I would go down 1 and to the right 1, or you can go up 1 and left 1. So go ahead and understand that's what slope is going to be. And then for your b value, remember that's a negative 1. So that means your initial value is going to be a negative 1. So on the y-intercept, you're going to put your first initial dot at 0, negative 1. So we can see that this is our x and this is our y. So going along the y-axis, since it's the y-intercept, we go to 0, negative 1. Since our slope is negative 1, or better yet, negative 1 over 1, like I said, I can go up and to the left. And I can keep doing this where I keep going up and to the left 1. Or what I could do is from that y-intercept, I can go down 1 and to the right 1. So I'm counting. How do I get to the next point here? By going down and to the right 1. So that first equation is here. So remember what I had just graphed was this y is equal to negative 1x minus 1. Now I'm going to go ahead and do that again, except now I'm going to go ahead and do that with my second equation. So here if I have a 3x plus y is equal to a negative 3, I can go ahead and subtract a 3x from both sides. So I can get that y is equal to a negative 3x minus 3, which tells me that my slope is a negative 3, or negative 3 over 1. So I'm going to go down 3 to the right 1, or I can go left, or I can go up 3, left 1. And my b-intercept is a negative 3, so that would give me a 0, negative 3. So I know along my y-intercept, my y-axis, I'm going to be at 0, negative 3. Versus my slope tells me to go down 3 and to the right 1. Or I could have gone up 3 and to the left 1. So then my second linear equation is graphed like this. So I know that wherever this point meets, and in particular this point is meeting at a negative 1, 0, that would be the solution. So the solution is going to be where these two lines meet, right? So they are going to meet at a negative 1, 0. So that's going to be the solution. And for the next problem, it's asking us how many solutions does the following system have? So you can go back to my lecture videos, but this here, I'm going to be using the method of substitution. Okay. And if you're unfamiliar with that, please look at my videos, or you can also go to Khan Academy if you want to understand this substitution method when you have a system of equations. So for these two linear equations, I can either cancel out the x or the y variable. And here, I'm going to go ahead and cancel out the x variable. So I see that my least common multiple of 3 and 9 is going to be 9. You might be wondering, like, how is she getting that? Well, if you have 3, you know that 1 times 3 is equal to 3. 2 times 3 is equal to 6. 3 times 3 is equal to 9. 4 times 3 is equal to 12. And you also know your 9s, which is 1 times 9 is equal to 9. 2 times 9 is equal to 18. And that first number that they both share in common is a 9. So that is how you're going to get your least common multiple of 9. So in order to make that first linear equation cancel out your second equation, you're going to go ahead and multiply everything by a negative 3. And you might be thinking, why am I multiplying by a negative 3? You're multiplying by a negative 3 so that when you add them together, they can cancel out. So if that's the case, then that first equation, when I go ahead and distribute a 3 into everything, I'm going to have a positive 9x minus a 6y is equal to a positive 9. And the second equation here, I didn't do anything to it. All I did is just write it over. So I have a negative 9x plus 6y is equal to a negative 6. Now I'm just going to go ahead and add these two equations together. So notice how the 9 and the negative 9 cancel out. Beautiful. And so does your negative 6y and your positive 6y. So it cancels out here, but now I have a 9 plus a negative 6. And that's going to give me a positive 3, which doesn't make any sense. So you would say this is a no solution. You can't have 0 and 3 have the same value. They cannot be equal because they're different numbers. So this is a different kind of word problem that you might encounter in Chapter 7. It says a company sells widgets. The company fixed and variable costs are modeled by the function C of x. Its revenue is modeled by the function R of x. How many widgets does the company have to sell to break even? Round your answer up to the nearest whole number if needed. So here, you really should know the definition of break even. And if not, you can refer back to my videos in lecture, which are found in Canvas. But in particular, we know that we have something that's going to break even, then we have your cost function is equal to my revenue function. So here, my cost function is given to me as a 0.81x plus 62,000. And that is going to equal to my R of x function, which is going to be my 9.7x. So all I did here was plug in my cost function, and I plugged in my revenue function. So the cost is equal to the revenue. Now to solve for this, I'm going to go ahead and combine my terms. So I'm going to subtract 8.81 from both sides. So I get 62,000 is equal to an 8.89x. From there, divide by 8.89. And so you are going to get on your calculator 6974.1282 is equal to x. And don't forget that it specifically said to round your answer up to the nearest whole number. So if I'm looking for the nearest whole number, that would be the 4 because it's the first number before the decimal. So that means I have to round up. So you need to sell 6,975 widgets to break even. For the next problem, it says, how many solutions does this following system have? So from here, what you really want to do is you want to be using your matrix on your calculator. Okay, so I'm going to go ahead and bring up my calculator, and just know that that's something that we're going to be using here. Now, I guess before we use the calculator, we have to put this into a matrix, so that way we can put this into the calculator later. So what we want to focus on are each of the coefficients for each equation in each row. So if I were to do that, I would have a 3, a 2, a -3, and a 1. So all I'm doing is making sure that I write this first row here. So then my second row would be here, and that third row, the coefficients, would be here. So I'm going to go ahead and do that. So now that I've written all of the coefficients in my matrix according to the row and the position, there's a couple of things you need to know. So this is, you can say, row 1. This is my row 2. This is my row 3. This is my column 1, my column 2, my column 3, and my column 4. So when you write your matrix, you always write it as a row by column. And in this situation, you would have a 3 by 4 matrix. So now that I know what my initial matrix is going to be, I'm going to go ahead and put that into my calculator. So I am going to go to the matrix. So I'm going to go to second, and then matrix. And here I have the different matrices. I want to go over to edit, and I want to go ahead and edit matrix A. So I know in matrix A, I'm going to be plugging in some values. I'm going to go ahead and put all of these numbers into this matrix. So I went ahead and made sure that I have all of these values into my calculator. And so now I want to go to second matrix, or actually I want to go to my home screen. There we go. So second quit to go to your home screen. Second quit after you enter all of your values in your matrix. So that's your home screen. So you want to go to second matrix, and you want to go to math. After you go to math, you're going to go to ref. And what this does is that it takes that matrix, you're telling your calculator, hey calculator, I want you to do some math stuff with this. And in particular, I want you to reduce this so that way I have my values for my x, my y, and my z. So in order to do that, to reduce this matrix into the values of the x, y, and z, you go to ref. So that's going to be B after math, and you click enter. And the calculator is asking you, well, which matrix, since you can store many matrices as many as you want on this calculator. So which one in particular are you telling me to reduce and give you the answers for? Oh, and you say, well, you go to second matrix, and you want that matrix A. That's where you stored all of this information into. So now I'm going to go ahead and click enter, and it gives me all of my values. So I'm going to go ahead and copy these values that I see on the screen onto my page here. So all I did was copy from the calculator onto my screen. So I put in those values. Now, for this particular matrix, something weird is happening. Look at this bottom row. So the bottom row is all zeros. So whenever that happens, it specifically tells me is that I'm going to have infinite solutions. And the reason why is because 0 is equal to 0. Whenever we have that case or that scenario, is an indication that we will have an infinite amount of solutions for this matrix. So for the next problem, it's specifically asking us to find the intersection between the line and a circle. So there can be three kind of different scenarios that happen. So if you're looking at the three different scenarios that can happen when you find the intersection of a line and a circle. Well, let's say we have this linear equation, and let's say we have this circle, and nothing happens, right? There is no solution. The line and the circle do not meet or intersect at any point. Now, what if I had, my line, and I had my circle such that it only hits it at one specific point. So that would be a one solution, since the line and the circle intersect at exactly one place. Now, if I had my line and I had a circle, this would indicate that there would be 2 points of intersections. So that would be 2 different solutions. Okay. Just to kind of give you a bit of a background. So now that I know that, what I can do to solve is I'm going to do a substitution. So in order to do a substitution, I need to get one of these equations by itself. So the first equation, I have a 4x plus y is equal to a negative 17. For my second equation, I have an x squared plus a y squared is equal to a 17. So in order to get this y variable by itself, what I can do is I can get that 4x to the opposite side by subtracting it. So I would get that y is equal to a negative 4x minus 17. So that means that whenever I see a y variable, I know what equation I'm going to be plugging in. Okay? So I have x squared plus, and what I'm plugging in there is a negative 4x minus 17, and its squared is equal to 17. So because I have this square, I'm going to go ahead and FOIL this out. And I'm just going to go ahead and pause it and do it since I don't want to take up too much time doing this video. So when I went ahead and wrote and FOILed that out, the purple is what I got, that 16x squared plus 136x plus the 289. So then from here, my next step is I see this 1x squared and this 16x squared. So I'm going to go ahead and combine like terms. And I'm also going to subtract the 17 to both sides so that way I can get a 0. So then from there, when I do that, I get a 17x squared plus 136 plus 272. So I'm going to go ahead and just copy this over so that I have more room. So now that I have it copied over, the next thing I want to do is think about how to solve this problem. So because I have this degree 2, I know what I can do is factor. And usually in factoring, you really want to come up with the greatest common factor, and that greatest common factor is going to be 17. So you end up getting an x squared plus 8x plus a 16 is equal to 0. And of course, when you factor this, you're going to have an x plus 4 and an x plus 4 equal to 0. So really, if you have x plus 4 is equal to 0, you're going to have x is equal to a negative 4. So you know one ordered pair, and that's the only one that you get. So you know you're going to have one solution. And that solution is going to be an ordered pair where you have some value for x and some value for y. And the only thing that you have right now is that x value. So what you know is that x is equal to a negative 4. So you want to plug it into one of the equations to get y value. And you can plug it into the first one, that's fine. Remember that you originally had this y is equal to a negative 4x minus 17. So you can plug in that x value of a negative 4. You do end up getting that y is equal to a negative 1. So your ordered pair, remember your x was negative 4. Don't forget that's what you had. That was that x value, and now you have that y value of negative 1. So that would be your one solution to this line and this circle. For this next equation, it says to graph the following system. So here, we really want to pay attention to the degree of each of these polynomials. It's degree 2. So that tells us it's going to be a parabola. And hopefully you guys remember your information about parabolas. If not, here's a quick review. So your quick review of a parabola. Remember, we're talking about that degree 2 inside your polynomial. So here, we can have a positive parabola. That means it's kind of, you can think of it as it's smiling at you, and your a value is going to be positive. You have a negative parabola if your a value is negative. And remember, our a value would be here. So it would depend whether or not it's positive or it's negative. And it would be facing down, sort of like it was frowning at you. And then we have the vertex. The vertex is the minimum or the maximum point in the parabola, depending on whether it's positive or negative. So if you have a positive parabola, then this vertex would be a minimum. And if you have a negative parabola, this vertex, right, would be a maximum. Okay? So that kind of tells us the general information about the graphs. Now, to find that minimum or that maximum value, the vertex, for a parabola, then you need to have the formula negative b over 2a, and that gives you the x-coordinate of the vertex. And if you want to get the y-coordinate of the vertex, remember it's an ordered pair. Remember, the vertex is just a specific ordered pair that's either going to be the maximum or the minimum point. So since it's just a point, you just need your x value and your y value. So here, the x value is going to be negative b over 2a. And the y, you have to plug it into your original equation to give you out your y value. So let's take a deeper look into these problems. So looking at this first equation, where y is less than or equal to a negative x squared minus 10x minus 25, I can go ahead and look at this coefficient, and that's my a value. So here my a value is a negative 1, my b value is a negative 10, and my c value is a negative 25. Since I have a is equal to negative 1, then I know that this is going to be a negative parabola. And remember, I know that it's going to be a parabola because I have that degree of 2. So whenever I'm thinking about this, I want to start thinking about the vertex. So if I want the x-coordinate of the vertex, I need that formula of negative b over 2a. So for my b value, I plug in a negative 10, and for my a value, I plug in a negative 1. And so when that is reduced, I get a negative 5. So that means for my vertex, if I'm thinking about my x and my y value, that x value is a negative 5. But I still need that y value. So remember, I have this original equation that I can use to plug in my value. And that value that I'm plugging in is a negative 5. And so when I plug that in, I do end up getting my simplified answer, and I end up getting a 0. So I have negative 5, 0. So I know that my parabola is going to be negative, and I'm going to have my vertex of a negative 5, 0. So I'm going to go ahead and plot negative 5, 0 on my graph. So I'm on my graph, and remember the vertex was negative 5, 0. Okay? So if that's the case and it's a negative parabola, I know more or less my shape is going to look like this. Now I'm going to go ahead and take a look at that second equation. So the second equation that they gave me was y is greater than or equal to x squared plus 10x plus 21. So I can get my a value as a positive 1, my b is a positive 10, and my c of a 21. So this tells me that I'm going to have a positive parabola, since my a value is positive. So if I want to find the vertex, then I want to think about negative b over 2a, which gives me the x-coordinate of the vertex. So the value that I'm plugging in here is going to be a 10 and an a as a 1. So when that reduces, I'm going to have a negative 5. And remember, the vertex, all it is an ordered pair, and I just found the x value to be negative 5. So now I can plug it into y is equal to an x squared plus 10x plus 21. Where that value that I'm plugging in is a negative 5. And I end up getting that y is equal to a negative 4. So the vertex for this particular parabola is going to be a negative 5, negative 4. And remember, it's going to be a positive parabola. So I'm going to go ahead and draw that. So remember, that parabola for that second equation was negative 5, negative 4. And it was going to be positive. So I'm going to go ahead and draw that out. So I went ahead and drew my vertex at negative 5, negative 4. And I know that it's a positive parabola, so more or less it's going to look like this. Now, here are some other things that you need to consider before you are done with this problem. Recall that these were inequalities. And whenever we graph inequalities, we have to shade. So for that first equation, it specifically says y is less than or equal to a negative x squared minus 10x minus 25, right? So we are dealing with that equation that has the vertex at negative 5, 0. So on the graph, I colored it and it was black. And so since its y is less than or equal, you can think of it as we're going to be shading everything below. So if I'm going to be shading everything below that, you can say it's going to be everything below is in here. Okay. Now let's go ahead and look at that blue equation now. So for that second equation, I do have y is greater than or equal to x squared plus 10x plus 21. So So I need to be shading everything above the blue equation. So everything in that blue equation is going to be in here. So the solution set is where it's blue and yellow, so where it overlaps. So where it overlaps, you can kind of think of it as it looks like kind of like a green color. So this, wherever it overlaps, would be there. That is your solution. Okay. So the solution will be where they overlap. So for this last problem, it's going to be the matrix again. So it says, given the system of equations, solve the system using Gaussian elimination. So you want to make sure that you put this into a matrix. So I'm going to go ahead and do that. So remember, what you do is you write each of the coefficients in each row. So in this particular case, I would have a 4, a 20, a negative 16, and a negative 40. So that represents the first row. Then I would have my second row. And then of course I would have my third row. So I'm going to go ahead and plug in those coefficients into this matrix. So now that I have those coefficients inside my matrix, I know that I have a 3x4 matrix. So I'm going to go ahead and call up my calculator. And remember, the way you do this is you go to second, and then matrix, and you want to go to edit, and click enter. You want to make sure that this is a 3x4 matrix, and then after that you want to plug in all of the values. So I went ahead and plugged in all of my values. So you want to go back to your home screen, and now that you're at your home screen, you're going to tell your calculator to find me the answers for the values of A, B, and C by making your calculator use ref. Okay, so I'm going to go to second, matrix. I'm going to go to math, go down to ref, click enter. Well, which matrix do you want me to reduce? The matrix that you entered into A, so the A matrix, and it has all of your values. So I'm going to go ahead and copy that screen onto my notebook. So then from here, remember you had your A and your B and your C value. So let's just go ahead and say this was your A, your B, and your C value and what everything was equal to. So this first row tells you that your A value is equal to 8. This second row, it tells you that your B value is equal to a negative 2. And that last row, it tells you that your C value is equal to a 2. And specifically, it says to write it as a triple ordered pair. So you want to write it as A, B, C, since it's in alphabetical order. So my A value is 8, my B value is a negative 2, and my C value is a positive 2. So that would be my final answer. If you guys have any questions, please feel free to email me. Thank you.